All right, when we want to undo a derivative that has chain rule as part of it, we use something called integration by substitution. So if the integral has both the function and the derivative of the function involved, we are going to substitute in place of our function u, and then by finding the derivative of both of these sides, we can make the integral easier to solve and then substitute back in to find the final answer. Let's look at an example. So we want to integrate this with substitution. So what you want to find is where is the function kind of within the function. And here the inner function would be what's in this parentheses right here. So that's what we want to set equal to u. And then what we're going to do is find the derivative of each side of this substitution statement. So the left side is just du. The derivative, the right side, 4 is a constant, so that goes away. Derivative of x cubed is 3x squared, and then dx, because we're finding derivative with respect to x. So now what we're going to do is make those substitutions. This whole inside will turn into u. The 3x squared along with the dx, that's what we see here, and so that's going to all turn into our du. So now our new integral that we're going to integrate here would become u. There's still that power of 5 there, and then the rest of that 3x squared dx turns into du. This is now an easy integral to integrate, and that's our goal with substitution, to make it easier to integrate and then substitute back in to find the actual antiderivative. So here we would go up a power to 6, put the reciprocal in front of 1/6 plus some constant of integration, because there could be a constant there where we take the derivative to get that. And then we substitute back in what we had u equal to. So here u is equal to this. We're going to substitute that back in now to get our final answer. So it would be 1/6 4 plus x cubed to the 6th power plus c. That would be our antiderivative right there. If we took the derivative of that using chain rule, we should end up with the same function that was in our integral to start with. Let's get another one, integrate this. So on this one, a little bit harder to see where the function is inside the function because it's not as apparent here. So on ones like this, then you just got to try something. We know though we'll never set u equal to just x, what we have on bottom here, because then all that's going to happen is all these are going to change it to u's instead of x's, and we haven't gotten anywhere. So I think our only choice on this one is to set it equal to the natural log of x. So then find our derivatives. du on the left side, derivative ln x is 1 over x dx. Okay, so now if we substitute here, another way of thinking of this integral, if we move that natural log out of there, would be natural log times 1 over x if we just separated that fraction out. So now we can see our substitution here. This is going to become our u. This is going to become our du. So now we have the integral of u du, which using our power rule here is 1/2 u squared plus c. Now substitute back in and we got our answer. It would be 1/2 natural log of x squared plus our constant. Once you try this one, pause the video and see what you come up with here. All right, let's see how you did. The function inside the function here is right here, so that would be our u. Derivative then becomes 2x dx. So when we substitute now, we're going to have square root of u. The 2x dx becomes our du. To integrate that one, hopefully you kind of thought of this as an exponent here. So using our power rule, again, add 1 to that, which would be 3/2. Reciprocal is 2/3. And then finally substitute back in. So should have came up with this answer if you had done it correctly.